Okay, so thank you both for joining me today on Future of Foods. We have Vincent Farrelly, who is in Ireland, and we have Özgür. Where are you based, Özgür?
So I'm based in Maynooth University, Ireland.
In Ireland as well. Okay, and can you and you both work in the fungi space. So this is a future of fungi as well as a future of food. So could you both give a brief introduction of who you are and how you're related to each other? Vincent, would you like to go first?
Thanks very much, Alex. Yes, my name is Vincent Farrelly, founder and CEO of Niskus Biotech. Essentially, what Niskus Biotech is doing is developing scale-up process technology to utilize underutilized side streams from the agri-food industry, such as breweries, spent grain, and to add value it by leveraging the power of fungi to create fungal-based products, such as food ingredients and feed ingredients. And we're basically working with research partners to develop the process and fermented products. And this is why we're working with Maynooth University and Özgür's team.
Okay, and so what do you supply to Vincent, Özgür? What's your specialism?
So I am fungal molecular biologist, so working with fungi more than 20 years, and I am leading fungal genetics and secondary metabolism laboratory. So we have wide experience on fungal secondary metabolites, so bioactive molecules that are produced by fungi, and we also provide expertise on fungal physiology, fungal growth, strain selection, and fermentation development systems.
Okay, so how are you working in a kind of day-to-day way with Vincent? What are you actually doing together at the moment? If that makes sense as a question, you know, what is the actual project?
So just if I can step in there, we're basically coming together to develop a process technology that will enable the conversion of spent grains, for example, into fungal products. And the challenge there is to be able to do this at scale. So there's a lot of, it's a combination of engineering and also a combination of selecting the right strain, getting the right growing conditions, and ensuring that you get consistency of bioactives being produced.
Right. Okay. So you are taking grains, spent grains, from breweries and such,
and distilleries, yes.
And so you are trying to find the perfect strain of fungi to grow in this particular media. Is that correct?
Yes. So there is a wide variety of strains that one can use, and where we're focusing on is using fungal strains that one can grow gourmet mushrooms on. So they're food grade, and as you know, the fungi are very, very powerful little biochemical factories, and they have ability to convert these side streams into high-value bioactives. So it's a case of aligning the fungi to the specific substrate with the goal of actually developing the bioactive or the byproduct that could also be fungal protein that can do this at scale. And that's the challenge that we have, and we're doing this in a kind of an incremental steps.
Okay. So the food product fungi is what? Is it one that people would recognize? Is it
yes.
Mushrooms or?
Yes. So you know, the mushrooms the fungi that we are using have been associated with the gourmet mushrooms. So we're talking about oyster mushrooms here. They're very tasty and healthy, and they have they're starting to come into more you can see them in more restaurants and supermarkets. And that is the fungi that we're growing. We have two options here. We have the option of actually growing the fungi on these side streams from the brewing industry, or we can actually just grow the roots of the fungi, which is called mycelium. And these mycelium produce interesting bioactives and also fungal protein that could be extracted. The trick is basically how do you do this in an economical and scalable manner?
Okay, so the mycelium, so you're sort of less interested in the fruiting body itself. You're more interested in the mycelium, perhaps, to extract the proteins from. Is that right?
Well, there's a journey here in which there's quite an overlapping process in which one is developing, that one could actually continue on and work with mushroom growers to grow those mushrooms, the fruiting bodies, utilizing these side streams that are widely available, such as burst grain. So that is one destination of the process, which we're working on, and it's actually nearer to market. Indeed, we're working with mushroom grower to actually to use this as a substrate to create these mushrooms, and he sells into restaurants, primarily into high-end restaurants, and that's a trade that could be grown. But where we see the future going forward is to actually grow just the mycelium, and that then is a lot quicker, a lot faster process. It takes under 10 days, and you can do you can have a conversion of the substrate into primarily mycelium, and from that then there's various different extraction technologies that you can extract all the goodness out of, be it enzymes or the fungal proteins or other bioactives. So that's where we're developing the process.
Okay, I get it. So clearly the advantage to using the mycelium is that because there are, as I know, there are two stages to growing the fruiting body. You have to grow the mycelium first in the substrate, and then from the mycelium, the fruiting body is grown. So it would take longer to get the fruiting body, and you don't necessarily get more proteins or more things from the fruiting body. Is that
there's two separate markets here. There's the fresh market, which is the fruiting body, which is a longer period of time. It goes on for a different process. It's generally grown in growing chambers, and there's the initial stage is the mycelium, and one can actually develop a system in which you can actually grow the mycelium up at scale. And we're talking here, how do you actually develop a system that is able to process multiple tons of the spent grain, because that's what these breweries and distilleries produce nearly on a daily basis. And how do you actually process that in an efficient manner to actually have a good conversion of that into mycelium-based product?
Okay. So in regards to sort of growing the fungi or the mycelium part of it, I mean, what are the problems? What are the hurdles you need to, what can go wrong?
Well, maybe if I could pass that over to Özgür, maybe some thoughts on that, please. So, as you mentioned, Alex, so that we have two parts, mycelia and the fruiting body. So mycelia generally also called vegetative stage. So the fungus basically take up the nutrients all the time and grows and produce masses of biomass. So that's basically long strings of these mycelia. So when the conditions are optimum for the mushrooms, so like certain humidity and certain temperature, then it produce fruiting bodies. So I think, so my expertise, particularly in early years of my career, I focus on in mold fruiting body formation. So a lot of factors can influence mold fruiting bodies, so like starvation, one factor, okay? Sometimes under starvation conditions, these molds, for example, they can undergo quick fruit body formation, and some stress condition even can be can induce fruit body formation, and light dark influence fruit body formation. So what can go wrong? So the point is, maybe if you cannot induce them in timely, so you will have less fruit bodies. That will reduce basically the yield of the production. But what we're interested here is there's a lot of value also on the, as Vincent mentioned, so on the mycelia. So the mycelia is always much easier to grow. When it comes to fruiting bodies, you have to have certain time period to induce fruiting bodies. So what we aim also here, we try to understand and also reduce the fruiting body formation, so that we can get more fruiting bodies from one set of growth conditions. So particularly, we are also interested in some strains that can make quicker fruiting bodies. So in the strain selection studies, so we can get some strains that can make quicker fruiting bodies, just doing some sort of strain improvement studies.
Okay. So by doing the strain improvements, I suppose you make them you make it so they can produce more mycelium, more fruiting bodies, but also that they are stronger against any kind of what's if you get bacteria in, I know it can destroy the whole lot, can't it? So if you improve the strains, would that improve their strength against infection by bacteria?
Well, we cannot know initially from initial studies if that will be the consequences. However, what we focus on here, as Vincent said, we focus on side stream materials. So it will be much different than the normal mushroom farms. So what we are interested in was solid in the liquid and some sort of semi-solid matrices growing these fungi and getting basically mushrooms and mycelia from these fungi. So in this context, we will work and with really a lot of care, so there will be less contamination to our system. So one of the major problem, if you work with the liquid cultures, you will have some contamination problem. So particularly if the mushroom grows enough, it will not allow to contamination also anymore, because it will generate some bioactive, so that will prevent the growth of the bacteria in this liquid media. It's initially, if we don't get contamination at the initial culture stage of these semi-solid or liquid cultures, so then we can get a lot of mycelium mass just to produce food materials, and also we can use these basically mycelial mass and also these liquid media to extract valuable bioactive compounds, so that we can use in pharmaceutical industry and also food biotechnology as food additives.
Okay.
Yeah.
And
so just to add to that is that the challenge that we have is to develop a process that's easy to integrate into a partner's processes that is creating these side stream. So the question is, how do you actually integrate what we're doing at scale into a brewery or distillery that's producing thousands of liters of this liquid waste or thousands of kilograms of the spent grain on a daily basis? And that's a challenge, because it's expensive to take these side streams off site. There's a timing issue, there's a degradation issue as well. And we're basically saying, how do we fit in a system that works well, that is near automated, that can actually create a valuable byproduct, fermented byproduct. And that's the challenge that we have. It's taken a system that's has been shown to work on a benchtop system or elements of it, and building that up in kind of like small pilot scale process, initially a small 1-ton pilot, and then building the knowledge and expertise to build up to a large facility that will either be on site on that brewery or or near site. That's what Niskus will be busy doing, hopefully over the next few years.
Okay, so of course this is exciting. You know, this is potentially a kind of you know, something that's very exciting for the breweries as well, to, you know, to be able to show that their waste is being used in some useful way.
Well, I mean, there's a number of things that have to be factored in. You know, we fast forward 5 to 10 years time, there will be incentives, more and more incentives for companies to be more circular. And there will also be penalties and fines for waste disposal. So currently what is happening, some of the side streams that are generated by these breweries and whiskey distilleries, they often go as an animal feed or go to a feed company. So that's traditionally what's happened. Sometimes the side streams spoil, or they're not able to be transported to a farm or to an animal feed company, and their destination is an anaerobic digester and sometimes landfill, or there's expensive disposal costs. So it's a case of kind of like broadening horizons and building partnerships with food companies, breweries, and enabling technology companies like Niskus and academic partners to say, is there better ways in which you can use this side streams and to have added value products and have cascade extraction processes as well? And that's where we're focusing on. And the brewery and distillery industry is a very nice case studies, because all breweries and all distilleries have near similar problems. They have an issue with their liquid side streams and have an issue with their solid state side streams. So what we would like to do is work with a few candidate breweries and distilleries, demonstrated a pilot that you can actually create value, work in cooperation with end users, such as food companies that are seeking more reliable or more new or more sustainable ingredients, such as proteins or aromas ingredients, and help build that bridge between these various companies. So that's what we're doing. So it's cutting ground, a novel area that we're working in, but we see over the next 5 to 10 years there's opportunities here to that many breweries and many distilleries in Europe will be having this valorization or micro-valorization process near or on site their premises.
It sounds very interesting, and I think there's certainly a lot of potential. So it's sort of oyster mushrooms. Are there any other mushroom strains that?
So we're using oyster mushrooms as our standard, test case. They're quite a diverse group of mushrooms that can actually valorize or break down a broad range of side streams, and they're also food grade. But there's opportunities to use to evaluate as we grow and diversify other types of mushrooms, both food grade and also maybe mushrooms that can be utilized for creating specific bioactives. Maybe also, if you want to come in here and describe some of the other options that can be developed or other bioactives that can be created.
Yeah, as we know, fungi, they produce tons of bioactives. So if you look at each fungus genome, we can see up to 50, 60 secondary metabolite gene clusters. So we think that only one secondary metabolite gene cluster synthesize one metabolite, let's say antibiotic, anti-cancer, or immunosuppressive molecule. So one fungus can produce up to 60 metabolites, but if we think only each secondary metabolite gene cluster produce one compound. But often the case, there is some crosstalk between the gene clusters. So this gene cluster produce, basically enzymes from that gene cluster produce one compound. That compound is converted by another gene cluster enzymes to another one. So we have some crosstalk that production of these metabolites could be more than 100. So the main thing is just to really to identify the metabolites from these fungal extracts and select the valuable ones and also concentrate on this. For example, sometimes a very valuable metabolite can be produced less, but as Vincent mentioned, if we grow them in the ton scale, so you can get these extracts and concentrate them using like HPLC systems, you can get them in high amounts. So that will provide high value for this, for the side streams, in addition to being used for the food, and also these extracts can be used just for the extraction of these high value fungal secondary metabolites. So as we know, antibiotics, like since 1930s, save millions of lives, like penicillin. Today, even we still use one of the strongest antibiotics and the broad spectrum. So fungal world has basically millions of these metabolites. So main thing that we select the fungi that grow well on these side streams, happily growing, producing good mycelia, and also can also produce nice fruiting bodies. So we cannot expect all of these different mushrooms will make high efficient fruiting bodies, but some of them will produce maybe better mycelia, but less fruit bodies. Some of them less mycelia, better fruiting bodies. But we will also know just analyzing those strains in the side streams and what kind of metabolites they're producing. So what we aim basically so normally the fungi, they produce, of course, under normal conditions, they make the fruiting bodies and they also activate secondary metabolite genes. They produce metabolites. So our aim is to understand if we can get conditions where the fungus only makes the vegetative mycelia but produce the same profile of secondary metabolites as it does during fruit body formation. So we can achieve that condition, so even we won't need the fruiting bodies. So we can directly use the mycelium mass just to make the foods and just functional foods, and also get the extracts from this fungus and then extract these valuable secondary metabolites, even the enzymes, just in addition to the raw material. Because as you know, fungi, they have a lot of functional molecules. So if you eat fungus, you get high rich beta glucans that will train your immune system, boost immune system. So it's always recommended to eat mushroom once a week to really train your macrophages in your body, because the beta glucans, they are very important molecules. So it's found in the bacterial cell wall, fungal cell wall, in there are a lot of pathogens like this. So once your cells eat them all the time, they are trained against also those pathogens. But that's also I was gonna
say that's very interesting. So and so you're saying that people should eat mushrooms once a week because it's good for their immune system. Does it matter what sort of mushroom they eat?
It doesn't really matter what sort of mushroom they eat. Main thing, all mushrooms, they have beta glucan in their cell wall, so they are rich in different sugars that have strong or potent effect in the immune system. But the main thing is there are some mushrooms, in addition to beta glucans, they can provide vitamin D. So, and some mushrooms, they might have like, what was it? There was one molecule similar to vitamin C. Actually, there's an antioxidant molecule, it's called argothioneine. So some mushrooms, they produce argothioneine. It's very strong antioxidant molecule. So basically, eating mushroom, you train your immune system, you get protein, you get bioactives, you get also antioxidants and vitamins a lot. So we can classify the mushrooms as functional foods. So they are naturally a functional foods, even if you eat them raw at some of the, some edible mushrooms.
But some mushrooms are better than other mushrooms, I suspect, right?
Yeah, that's here. I believe that Vincent
Yeah. So
can
yeah.
answer here.
So basically, we see increasing interest in gourmet mushrooms, shiitake, lion's mane, maitake, oyster mushrooms, king oyster. Not only are they tasting very nice, they've got a meaty texture, in some cases flavor. Or, the likes of lion's mane has kind of a shrimp, lobster flavor. So we're seeing that there's an interest in using them as meat alternatives or to complement people's diets as a nutraceutical. So often, people can consume that in a supplement. Where we would like to see people consuming more of these gourmet mushrooms as part of their daily or weekly diet, both in fruiting body and also in extracts. So they have been associated with kind of improved overall general health, immune health, and there's some publications associated with some of these mushrooms improving, being a benefit for people who have memory loss or onset of Alzheimer's.
Yes, it's clear to see why fungi and mushrooms are interesting and of great value. To all things from kind of recycling to sort of packaging to clothing kind of dyes to brain functionality and etc. It's almost kind of never ending what they're capable of. I wanted to ask you, Özgür, how did you first become interested in fungi research?
Well, originally I did my master's studies in yeast. So, as you know, the yeast is quite versatile organism. So we use it just in bakery to make bread and also for our drink. And that some big drink giants, they produce their beverages, beer production. So, but then I switched to filamentous fungi, just seeing that they have more use than yeast. So of course, yeast contributed basically to all just development of humanity. Basically mankind is using the mushrooms the last 3,000 years. So we can see the records that people are using in China, different mushrooms for the treatment of different diseases. And we also in folklore, we consume the mushrooms. So just seeing the importance of the mushrooms and filamentous fungi, so I decided to do a PhD to understand this versatile nature of this fungi. So therefore, during my PhD, I studied more in a group in Germany, in Göttingen, fruit body formation. So many fungi, they produce fruit bodies. Either they're molds, little filamentous fungi, which are microscopic fungi, but we have also macroscopic fungi, all mushroom families. So they produce basically the fruit bodies, or these are growing structures. So basically that made me very interested in their versatility. So far, I have been doing a lot of molecular research and then understanding the genetic regulation and of fruit body formation, also production of fungal bioactives. So how light controls, how nutrient level controls, and finally what are the outcomes of this control, and how the production changed during in the light and dark fruit body, how it's produced. And I'm also interested in more mycotoxins. So mycotoxins are a big problem, probably a topic of another podcast. But so just seeing all these, and it's now the time that to transfer all this knowledge to do basically at the industrial level. So we are collaborating with Vincent, and then just to basically transfer all this knowledge of this genetics, biochemistry, and physiology into production of that valuable fungal foods and fungal derived bioactives and also enzymes. Just using
mycotoxins.
Yeah.
So, I mean, I am interested in the mycotoxins. So this is the ability of fungi to kind of clean waste. Is that right? Is that what you were
No,
that's something
no,
else?
that's bioremediation.
Okay.
Maybe you might talk a wee bit about bioremediation.
Yeah.
Yeah.
Yeah. That's
So
interesting.
basically, yeah, the mycotoxins are the notorious compound that are harmful to animal and human health. So,
Okay.
so basically, mycotoxins are also one group of secondary metabolites. So fungi, in addition to the beneficial molecules, they also produce these dangerous and deadly molecules, mycotoxins. So if they are contaminated food sources like aflatoxins, there's a big problem in Africa and Asia. So they, in the long-term consumption, can lead to, for example, liver cancer in the aflatoxins. But as Vincent mentioned, as just the bioremediation is another part of fungi. So we are all coming to point that fungi are at the center of a sustainable world. So bioremediation is basically use of fungi to like detoxify the heavy metals from soil, because fungi can accumulate and detoxify, basically to trap the heavy metals, for example, and they can be used for the cleaning up the wastewaters, because they can also degrade the xenobiotics, which are some drug residues, chemicals found in the wastewater. So that the fungi, their ability, a lot of enzymes to break down these xenobiotics and then clean the waters. So these are, we call it bioremediation. So even there are some recent years, there are some also progress in the degradation of the plastics by fungi. There are some studies, although they are not really, they haven't discovered yet very important enzymes, but so fungi can be used for bioremediation at every aspect. Anything that you would like to add, Vincent, on this?
Just, I mean, basically, once you enter into the world of fungi, there's so much opportunity to create different products and services across many different sectors, ranging from food, beverage, bioplastics, bioremediation. So there's great scope. So what we're doing here is we're developing a process for a small subsection of that, how to initially how to upcycle brewers grain and whiskey spent grain, and to create high value food ingredients and feed ingredients.
Okay.
And we're only selecting food grade gourmet mushrooms, the types of mushrooms you would eat in restaurants. They're the mushrooms that we're growing. So they're perfectly safe mushrooms, and their byproduct and the products that they create are perfectly safe. Indeed, there's growing evidence that some of the bioactives that these fungi produce have great beneficial health benefits to to general health.
So what do you need? So what do what are you looking for at the moment to kind of help grow?
So the next steps. I mean, we're a small company, but we've lofty ambitions. We want to grow this company. We're based in Ireland, but we're very keen in building international partnerships. The problem we're solving is an international problem. Every brewery and every distillery around the world has this problem, and not only even in the food industry. Every food manufacturer has a underutilized side stream that they're currently increasingly having difficulties of finding uses of that. And often those side streams, if they're left for any period of time, go off and they become expensive waste streams for them. So we're interested in working with food companies and beverage companies that have these side streams and want to be innovative and want to actually create value. And through our process that we're developing, we would like to work with them to help them create value. And on the flip side of that, we're very keen to work with food companies that are seeking more secure sources and more sustainable sources of their food ingredients, such as proteins, aromas, and nutraceuticals, of which these fungi can produce them. And we're also interested in working with companies that have associated enabling technologies, such as extraction technologies, that could dovetail into our process. And as a startup, yes, we're keen to forge links with very good research groups, such as we have here in Maynooth. And yes, we will be seeking, investment, follow-on investment. So we're looking for investors that invest in food processing technologies.
Okay, all right. Well, that's it's very interesting to kind of think about what's possible in the world of fungi, in the future of fungi. So, I mean, this is a bit of a kind of curveball question to end on. Özgür, what do you think might be one of the most exciting things that fungi can offer us in 10 years from now?
Well, this is an important but also difficult question, because fungi, they can offer in 10 years many things. So as we are trying here, so we can use all these side streams, all these basically beverage industry and also food industry, to use all these side streams and turn them into economic value. So nothing is wasted. So basically then we can squeeze out everything, all the energy, all the nutrient values, and all basically everything out of these agricultural products, turn them into the valuable products. That's probably almost with zero loss. So we then turn them into drinks, beverages, bioactives, and proteins. That's one thing that's very, very important. But in the second part is, I believe the fungi will be used more in the construction industry, and will be used more in the bioremediation of the earth, because our earth is getting polluted, just getting more and more polluted. So we are having more heavy metals, more chemicals in the environment. So, and there will be probably some plants in the future using the fungi or fungal enzymes to basically remediate the wastewaters, and probably we will be degrading the plastics in some large plant fermenters with some fungal enzymes, adding it, and then turning them into a valuable carbon-rich molecules, which can be reutilized by other processes, turn other byproducts. So there's a broad future. But we have also large, like bioactives. So far there's estimated 5 million fungal species. So we only know only 60,000 of them. So we don't know the rest. So each of them have valuable genes, valuable enzymes, valuable metabolites. So we might see a lot of maybe anti-cancer compound and new classes of antibiotics coming from fungi that will magically treat the diseases coming from bacteria, fungi, viruses, and we can also use them in the treatment of some cancer types maybe. So there's a big picture.
It's certainly a very exciting prospects to see what's possible. Who knows, we may even sort of find a fuel from fungi in some way, some kind of power source. So
actually fungi are already used in biofuel production. So I know a colleague of mine, Gustavo Goldman, doing a lot of work there, this conversion of these sugar cane into bioethanol production. But still these are, just still that we use these fuels, just burning them, generating CO2. So we have to look at from the green side, a more circular way. So it'll be potentially could be that fungi could be producing some sort of fuel. So who knows? So maybe some enzymes, some enzymatic processes, one can produce some
Yeah.
magical fuel in 10 years.
Just to add to that, we're entering into that. We are in the biocentury, and the future will have fungi written into it, and there is a need to. What we're finding is there is a need to actually develop the technology and the process that will scale and actually dovetails into existing processes, and that is a challenge because there's many silos, and what we would see is that process technology will help build bridges between non-traditional companies that have not worked with each other but could actually be of benefit to each other. But we're using the fungi and the process to be those little small biochemical reactors that they are. They're little biochemical factories, and they can then be programmable to make desirable bioactors or whatever the market is demanding. And it's to essentially, how does one develop a robust enough process that is flexible to actually create a broad range of desirable fermented products?
Yeah, I mean, it's fascinating. I mean, I was already fascinated in fungi before I spoke to you two, so it's an area of particular interest to me, and I would be interested to sort of follow further what you do. So let's stay in touch, and thank you for coming on and talking to me.
Thanks, Alex.
Thank you,
You've got
Alex.
sunshine over there in Ireland, like we have
Yeah.
here, so you can go out and
we're enjoying the rest of the summer.
Yes, great.
Yes.
Thank you very much. You both.
Right.
Okay, thank you.
Thank you.
All the best.
Bye-bye.
Bye-bye.
Bye-bye. Bye.